We are living in a golden age of space exploration. Yet we are slowly imprisoning our planet within a massive and growing cloud of orbital garbage. A tiny fragment of paint, smaller than a grain of sand, orbits at 28,000 kilometers per hour, carrying the destructive kinetic force of a grenade. When these invisible bullets strike, they can instantly disable multi-billion-dollar communication networks, leaving us blind and disconnected in an instant across the entire globe. In 1957, the space above us was pristine. Today, it is crowded with millions of fragments from old rockets, dead satellites, and broken hardware. If we do not take action immediately, the very gateway to the stars will become a lethal graveyard, trapped behind an impenetrable wall of our own making. Inside Mission Control, the engineers monitor the sky with growing anxiety. Every day, they must execute complex maneuvers to avoid catastrophic collisions that threaten our astronauts. The margin for error is shrinking. A near miss is no longer a rare event, but a daily reality that haunts the people responsible for our safety. Time is running out to clean the orbital lanes. Every second we wait, the probability of a catastrophic event that changes human history forever increases significantly. This is the beginning of the final scenario. It is a warning from the void that humanity's future in space hangs by a very thin, fragile thread. Scientists around the world are sounding the alarm. We are at a tipping point where one single mistake could trigger a disaster we cannot stop. Without a global cleanup strategy, our legacy in space will be nothing more than a ring of junk that isolates us from the rest of the universe. We owe it to the next generation to keep the heavens open. The cleanup mission is not just a choice. It is a matter of survival. To understand the danger, we must look at the Kessler Syndrome. It is a terrifying chain reaction where one collision creates thousands of new, lethal projectiles. Donald Kessler warned us in 1978. Once the density of objects reaches a critical mass, a single crash will trigger a cascading wave of destruction. Each new fragment becomes a weapon. In this orbital shooting gallery, there is nowhere to hide once the dominoes start falling at 17,000 miles per hour. The Kessler Syndrome is not just a theory. It is a mathematical certainty if we continue to launch without cleaning up the mess we leave behind. Imagine a world where the internet goes dark. Global finance, emergency services, and navigation systems would collapse instantly if our satellite network were destroyed by debris. Your phone would lose its connection to the stars. Google Maps, weather forecasting, and international banking would become relics of a lost, more advanced technological era. Communication would revert back decades. The seamless connectivity we take for granted would vanish, replaced by the silence of a planet cut off from its orbital infrastructure. Experts describe this as the end of the space age. We would be trapped on Earth, unable to launch even the simplest missions for many centuries. History would remember us as the civilization that reached for the stars, but ultimately blinded itself by filling the sky with high-speed, uncontrollable metal trash. This is the nightmare that keeps aerospace engineers awake at night. A self-sustaining cycle of destruction that we currently have no way to turn off. Every launch becomes a gamble against impossible odds. The cost of insurance and the risk of failure would make space travel economically and physically impossible. But there is hope. A new generation of engineers and private companies are rising to the challenge, developing revolutionary technologies to clean up our cosmic backyard. Companies like ClearSpace and Astroscale are turning science fiction into reality. They are building the world's first dedicated space tugs to capture drifting orbital debris. The mission is incredibly complex. Imagine trying to catch a moving car while traveling at 20 times the speed of sound in a total vacuum environment. The space net is made of high-strength fibers. It is designed to wrap around erratic, tumbling objects and stabilize them before they can cause further damage. Before going to space, these systems are tested in giant pools to simulate the microgravity environment, where every movement has an equal and opposite reaction. Another bold solution is the Space Harpoon. This device fires a titanium spike into the hull of a dead satellite, tethering it to the Hunter craft. Once caught, the Hunter uses its thrusters to drag the junk out of its dangerous orbit, acting like a cosmic tow truck for the modern era. Data shows that removing just 5 large pieces of debris per year can significantly reduce the risk of a Kessler Syndrome event in the near future. The final destination for this trash is the atmosphere. Friction with the air generates intense heat, vaporizing the debris into harmless dust during a controlled re-entry. What looks like a beautiful shooting star is often the successful conclusion of a cleanup mission, returning the material back to the Earth as light. Every successful test brings us closer to a cleaner sky. These engineers are the pioneers of a new industry, one that cleans instead of just building. But we don't always need to touch the debris. The ELSA-d mission is testing the power of giant magnets to capture metal objects without physical contact. Magnets provide a safer way to dock with tumbling satellites. By using electromagnetic forces, we can stabilize a piece of junk from a safe distance before moving. This invisible hand allows for precision maneuvers that mechanical claws struggle with. It is an elegant solution to a chaotic and dangerous physical problem in orbit. On the ground, massive laser arrays are being developed. These aren't weapons designed to destroy, but tools designed to push and nudge objects into safer paths. The laser creates a tiny amount of thrust on the surface of the debris. Over time, these small nudges can change a collision course into a safe miss. Laser technology can handle the millions of small fragments that are too small to catch with nets, but large enough to destroy a space station. The ultimate goal is to guide larger debris to Point Nemo, the most remote place on Earth, where they can sink safely to the bottom of the ocean. We are mastering the invisible forces of the universe. Our magnets and lasers are the silent protectors of our orbital infrastructure, working quietly in the background of history. These technologies represent a shift in our approach to space. We are no longer just explorers. We are becoming the responsible stewards of the cosmic environment. It is a race against physics. Every piece of junk we remove today prevents 1,000 new pieces from being created in a collision tomorrow afternoon. There is no single silver bullet. A combination of these innovative methods will be required to effectively clean the different layers of our crowded orbital shell. Future satellites will come equipped with docking plates and self-destruct mechanisms, ensuring they never become part of the problem once their mission is finally over. The industry is changing. We are building sustainability into the very core of spaceflight, learning from the environmental mistakes we made during the Industrial Revolution. Artificial intelligence will lead the way. Sophisticated algorithms will coordinate thousands of cleanup drones, managing the traffic of a cleaner and much safer orbital highway. This is a global mission, from NASA to the European Space Agency and private startups in Japan. The world is uniting to protect our common interest. We are the janitors of the stars, says one leader. It is a role that carries immense pride, as they are the ones securing the future. The scale is staggering. More than 30,000 large objects are currently being tracked, but millions of smaller, untraceable fragments pose an even greater silent threat. They work through the night, calculating trajectories and refining capture methods.
Cheers to the team.
Every line of code they write is a shield for the astronauts orbiting above us. International cooperation is key.
We did it.
Space has no borders, And the debris created by one nation becomes a lethal hazard for every other nation on the planet. The success of missions like DART proves that we have the technology to move celestial objects. We are applying these same principles to clean our orbit. We are listening, watching, and preparing. The infrastructure for a global space traffic control system is being built right now to prevent future accidents before they happen.
Initiating sequence.
Innovation is coming from everywhere. Even students are contributing, launching small experiments that could lead to the next big breakthrough in environmental space science and engineering. The race is on. This is not a race for dominance, but a race for preservation. It is a competition to see who can be the most responsible. Every successful removal mission is a victory for all of humanity. It is one less bullet flying through our orbital lanes, making the sky a bit safer. Precision is our greatest ally. In the vastness of space, a few centimeters can be the difference between a successful cleanup and a disastrous multi-fragment collision. We are reclaiming the sky. Piece by piece, we are opening up the green zones where new missions can thrive without the constant fear of destruction. Our astronauts deserve to work in a safe environment. They are the pioneers on the front lines, and we are their support team back here on Earth. The space economy is worth hundreds of billions. Protecting it is not just an environmental goal, but an economic necessity for the future of global commerce. The next step is recycling. Why destroy the metal when we can use it? Future stations will capture junk and turn it into fuel for deep space missions. This is the vision of a sustainable future. A world where space is not a dumping ground, but a resource-rich environment that we manage with extreme care. From a distance, the debris is invisible. But for those of us who live here, it is a barrier we must dismantle to reach our full potential. We do not inherit the universe from our ancestors. We borrow it from our children. Their right to explore the stars depends entirely on our actions today. Don sach quy đạo không chỉ là giải quyết sai lầm quá khứ, mà là mở đường cho những bước chân tiếp theo của nhân loại tới các vì sao xa xôi. If we succeed, the moon will be our first true stepping stone. A clean orbit means a clear path to lunar colonies and the mysteries of Mars. Our legacy will be defined by how we cared for the commons. The cleanup campaign is a testament to our growth as a truly spacefaring, responsible civilization. This is a story of human ingenuity overcoming human neglect. It is proof that when we face a global threat, we have the power to fix it. The dawn of a new era is here. An era where we no longer leave a mess behind, but leave a path for those who will follow. The stars are waiting. By cleaning our own backyard, we are finally ready to step out into the neighborhood of the universe with our heads held high. Every piece of trash removed is a promise kept. A promise that the sky will always be open, and that humanity's journey has only just begun to unfold. We protect to explore. This mission is our gift to the future, ensuring that the light of the stars will never be obscured by our own debris. The cleanup is a success. The sky is clear, the path is open, and the future of humanity among the stars is now safer than ever before.